During CES 2025, Nvidia announced the GeForce RTX 50 series and its CEO was super excited to share with us the performance improvements AI offers to gaming. This is the first time that AI has provided such an improvement in gaming, and Nvidia has fully exploited its capabilities to lure gamers into the next era of gaming. There was a lot of criticism about whether the performance improvement through the AI-generated frames is actual, and we will find out this through this review, so stay with us. According to Nvidia, neural rendering is the next era of computer graphics. By integrating neural networks into the rendering process, Nvidia states that it can provide dramatic leaps forward in performance, image quality, and interactivity to deliver new levels of immersion. Rasterization is a technique that produces an image as seen from a single viewpoint. This is what GPUs use from the start. As modern GPUs became stronger and stronger, rasterization allowed for real-time graphics like the ones we see in games. Moreover, the increase in GPU power eventually led to 3D gaming as we know it nowadays. In a few words, ray tracing creates more realistic scenes by accurately showing lighting. It doesn't only show what is visible from a single point of view, but it shows what is visible from many different points of view in many different directions. It works by shooting rays into a scene from the camera's viewpoint. These rays interact with the scene's objects, and the effects of these interactions have to be shown accurately, which demands heavy computing power to show the correct ray paths and the corresponding ascents. If this wasn't enough, the first interaction of a ray hitting an object and the ray's reflections on other objects must also be calculated for a more realistic outcome. In real life, shots of rays affect the entire scene. The same applies to graphics, where all pixel information must be considered for the highly realistic result. This is extremely demanding in real time, even with today's hardware. Nvidia and AMD introduced various techniques for real-time ray tracing, minimizing the computational power required for realistic scenes. Path tracing is a method of modeling real-time dynamic lighting in a scene, and it is not new at all since it originated in the mid-80s. In 1986, Caltech professor Jim Kajia's paper, The Rendering Equation, connected computer graphics with physics through ray tracing and introduced the path tracing algorithm, making it possible to represent how light scatters throughout a scene accurately. Rasterization casts one set of rays from a single point, which vanishes when they hit the first object. Ray tracing casts rays from many points in any direction, and finally, path tracing tries to truly simulate lighting physics, having ray tracing as one of its components. Nvidia initially created DLSS super resolution to utilize a convolutational autoencoder AI model and reconstruct a high-resolution current frame on a pixel-by-pixel basis from the low-resolution current frame and the high-resolution previous frame. So, DLSS trains the AI model to predict an ultra-high-resolution reference image. The difference between the predicted and reference image is used to train the neural network. This process is repeated thousands of times until the network can predict a high-quality image. According to Nvidia, DLSS ray reconstruction, DLSS super resolution, and DLAA will now be powered by the graphics industry's first real-time application of transformers, the same advanced architecture powering frontier AI models like ChatGPT, Flux, and Gemini. DLSS transformer models improve image quality with improved temporal stability, less ghosting, and greater detail in motion. The significant difference between the frame generation on the RTX 40 and 50 series is that the latter will allow the generation of up to 3 frames, offering a way higher performance boost. DLSS multi-frame generation generates up to 3 additional frames per traditionally rendered frames, working in unison with a complete suite of DLSS technologies to multiply frame rates by up to 8 times over traditional brute force rendering. According to Nvidia, this performance improvement allows for 4K 240 FPS fully ray-traced gaming on the RTX 5090. In the initial DLSS frame generation introduced in the RT40 series, an optical flow accelerator provides to the DLSS algorithm the required data to generate a frame using a neural network from information retrieved from the previously rendered frame, so the final result is double the frame rates, aka FPS performance. In multi-frame generation, AI takes over the optical flow generator's place, predicting up to 3 frames from an actually rendered frame, so in essence we get 3 more frames instead of only 1 from an actual one. Suppose the rendered frame is produced through super resolution and we have set the frame generation to the maximum performance, generating 4 times the pixels from a single rendered pixel. In that case, we can have frame pacing problems. What is frame pacing? Assume that this is the proper sequence of frames displaying in 1/6 of a second in a 30 FPS game with proper frame pacing. Each frame, 1 to 5, is repeated once, so there is smooth motion. Now, in a game with frame pacing issues across the same period, you can get something like this. In this example, the third frame takes longer to render, so the second frame has to repeat, and frames 3 and 4 don't remain as long, with frame 5 repeated 3 times. This results in a choppy, not smooth game feeling. DLSS 4 uses dedicated hardware to address frame pacing, which is included in Blackwell's display engine hardware, and reduces frame variability by 5 to 10 times. Previously, DLSS used convolutional neural networks, CNNs, to generate new pixels by analyzing localized context and tracking changes in those regions over successive frames. After 6 years of continuous improvements, we've reached the limit of what's possible with the DLSS CNN architecture. The new DLSS transformer model uses a vision transformer, enabling self-attention operations to evaluate the relative importance of each pixel across the entire frame and over multiple frames, employing double the parameters of the CNN model to achieve a deeper understanding of the scenes. The new model generates pixels that offer greater stability, reduced ghosting, greater detail in motion, and smoother edges in a scene. According to Nvidia, in intensive ray tracing content, the new transformer model for ray reconstruction delivers a significant uplift in image quality, especially in scenes with challenging lighting conditions. For example, in scenes from Alan Wake 2, stability is increased on the highly detailed trailing fans, ghosting on the fan blades is reduced, and shimmering is eliminated on the power lines, improving the player's immersive experience in the third-person game. RTX neural shaders bring AI to programmable shaders. 25 years ago, Nvidia introduced GeForce and programmable shaders, unlocking new chapters in graphics technology, from pixel shading to compute shading to real-time ray tracing. Nvidia is now introducing RTX neural shaders, which bring small neural networks into programmable shaders, enabling graphics capabilities. The applications of neural shading are vast, including radiance caching, texture compression, materials, radiance fields, and more. The RTX Neural Shaders SDK enables developers to train their game data and shader code on an RTX AI PC and accelerate their neural representations and model weights with Nvidia Tensor cores at runtime. During training, neural game data is compared to the traditional data output and refined over multiple cycles. Developers can simplify the training process with Slang, a shading language that splits large complex functions into smaller pieces that are easier to handle. Reflex 2. In 2020, Nvidia released Reflex, a technology that reduces PC latency in top competitive games by an average of 50%. Nvidia Reflex accomplishes this by synchronizing CPU and GPU work, so player actions are reflected in-game quicker, giving gamers a competitive edge in multiplayer games and making single-player titles more responsive. Nvidia Reflex has been integrated into over 100 games in the last 4 years. According to Nvidia, over 90% of gamers turn Reflex on, allowing them to experience better responsiveness, aim more accurately, and win more games. Coming soon to popular game titles is Nvidia Reflex 2, which can reduce PC latency by up to 75%. Reflex 2 combines Reflex low latency mode with a new frame warp technology, further reducing latency by updating the rendered game frame based on the latest mouse input before it is sent to the display. The box has white themed graphics and it's sturdy enough to protect the expensive card. Packing foam surrounds the graphics card. The package includes one-click sync Pro cable, PCI Express 16-pin to 3 8-pin adapter and metallic support stick. I suggest avoiding adapters and buying a PSU with a native 12+4 pin connector. Remember that 12+4 pin connector cable between RTX version 3 and version 3.1 PSUs remains the same, only the header changes if the PSU uses a native 12+4 pin header instead of two 8-pin ones. The graphics card has a compact design thanks to its small PCB and cooling solution. The metallic backplate is a nice detail, protecting the card's back PCB while also assisting in its cooling. The available display ports are 3 display port 2.1B and a single HDMI 2.1B. The main parts of the graphics card are the backplate, the cooler, the PCB and the fan assembly. The cooling solution uses 7 heat pipes which pass through the block that comes in contact with the GPU. The GPU 203 follows the Blackwell architecture. TSMC manufactures this GPU and uses a 5 nanometer production process like its predecessor. Its die size is 378 square millimeters and it has 45.6 billion transistors. It has almost the same die size as the AD103 used in the RTX 4080 and has the same amount of transistors. This image explains everything you need to know about this graphics card and its power secrets. It was provided by our friends at Tech Lab. Big thanks to Ronaldo and Bertie, who are experts in GPUs and not only. All credit for this part analysis goes to Tech Lab, who also trained me on how to do that properly. A 10-phase VRM powers the GPU, highlighted in the green rectangles above. A 10-phase VRM powers the GPU. A monolithic powered systems MP29816 controller controls this. There are 4 phases for MSVDD and 2 phases for FBVDD. For those who don't know what these two mean, FBVDD ensures the stability and accuracy of data transfers between the GPU and memory, especially at high clock speeds. In contrast, the MSVDD voltage manages the memory chip's operation. The GPU power phases use monolithic MPS MP87993 DRMOS rated at 50 amps. The VRAM phases use the same DRMOS type. Samsung makes the GDDR7 memory chips. They are rated for 32 GPPs. The weird thing here is that the RTX 5090 uses the same memory chips but rated at 28 GBPs. The card's power socket is type 12V 2x6. There is no information on the fan model numbers, but they most likely use rifle bearings like the rest fans that GALAX uses in its GPUs. In this table you will find all games that I test and their respective settings. Too much work, guys. Relative performance and performance per watt, raster. The relative performance difference with the RTX 4080 is low at FHD, but at least it achieves first place in performance per watt, not by significant difference. At QHD, the RTX 4090 is far away, while the RTX 4080 is around 4.6% lower. In performance per watt, the difference with the RTX 4080 is low. It is around 6% better than the RTX 4080 in performance and almost the same in performance per watt at 4K. The RTX 4090 is far away in performance. Relative performance and performance per watt, ray tracing at FHD and with RT enabled, the difference with the RTX 4080 is low at close to 4%. The performance per watt improvement reaches 6%. At QHD, the performance difference with the RTX 4080 is at 6% and there is a notable improvement in performance per watt. At UHD, the performance difference with the RTX 4080 is at 9%, and the improvement in performance per watt reaches 7.5%. Raster and DLSS, because there seems to be an FPS limit cap on Warhammer in the RTX 5080, the RTX 4080 has a slight lead here. The same goes for performance per watt, this at Full HD. At QHD, the RTX 5080 is a bit above 4% ahead of the RTX 4080. The difference in performance per watt is lower at 3.5%. The difference with the RTX 4080 is close to 11% at UHD, with a performance per watt boost being close to 6%. Ray tracing and DLSS at Full HD, and with both ray tracing and DLSS enabled, there isn't a major performance difference at Full HD. In performance per watt, the improvement is a bit above 4%, the performance gap is 4.5% at QHD, and the performance per watt improvement at 7.5%. Almost 10% better at 4K and 8.4% better in performance per watt. Ray tracing and DLSS and frame generation. With frame generation enabled, the RTX 5080 is 8% better at Full HD than the RTX 4080. There is also a 10% improvement in performance per watt. At QHD, the performance improvement is at 11%, and the performance per watt boost is also notable at 13%. This is the largest difference I noticed at 15%, while the performance per watt boost is a little lower at almost 14.5%. I used the same frame generation for all cards in these charts, 2x frame generation. Excellent rendering performance for the RTX 5080. The V-Ray score is notably higher than the one that the RTX 4080 achieved. Operating temperatures: idle, low temperatures; multimedia, low temperatures; rendering, low enough temperatures; gaming with RTX off, low temperatures; gaming with RTX on, low temperatures; Fairmark, low temperatures. Operating noise: fans full speed 75% and 50%. Thanks to the fan stop feature, most graphics cards are dead quiet at idle and multimedia. The GALAX RTX 5080 is also silent in rendering. During short gaming periods, the GALAX card is silent. In Fairmark, where the card is stressed, the output noise is above 29 decibels, which is high enough. Frequency plots: 30, 41, 49, 50, 51, 57, 58, 75%. The peak frequency is 1000 Hz. At full speed, the peak frequency is 1.6 kHz. I have recorded all signals, but I've enabled automatic gain control to make it easier for you to reproduce them. With one or two monitors connected, power consumption in desktop and idle is high. The weird thing is that with a single monitor connected, the power consumption was higher than with two monitors connected. Media playback power consumption is increased. Gaming power consumption is close enough to the RTX 4080, but above in most cases. The card reaches its TDP 360 Watt in the average power consumption, and in rendering the power consumption is also increased, not by a large margin though. The peak power consumption is notably lower than what I measured in the Asus RTX 4080. The clocks are high in all cases, even in Fairmark, where I push the GPU to its TDP. In multimedia playback, the lower the GPU speed, the better. Overclocking: I dialed up to 2750 MHz for the GPU's boost clock and 34,000 MHz for the VRAM, and everything worked fine. The overclocking room is significant, especially for VRAM. This is 32 GPP's rated RAM after all. I could push the card higher, but my time is restricted. A close to 7% performance gain through overclocking is good. You can easily push this card to exceed 10%, at least in synthetic benchmarks, but note the power consumption will further increase, so you have to have a good and strong PSU installed. The power consumption difference is at 33 Watt on average and 40 Watt at peak. The temperature differences are low because the fans spin at 116 RPM faster in overclock mode. The cooling system works well, but we must also look at the GPU clocks to get the complete picture. The GPU clocks are high, so combined with the low temperatures, we can say that GALAX uses a good cooling solution in this cut. The average performance difference between the RTX 4080 and the RTX 5080 is just 7% using the same DLSS and frame generation technology, while the power consumption improvement is even lower at 6.31%. This is nothing to get you excited. I will use a phrase I read in a comment in one of our videos. This new GPU release is mainly a software update. So true, guys. With DLSS 4 enabled, you get higher quality graphics, and with the new frame generation modes 3 and 4 times, which are only available in the RT50 cards, you can get way higher performance. It is all about AI, after all, to improve performance. So, let's look at two games where I went for the full frame generation speed, 4x, and notice the differences. The performance with frame generation 4x renders the RTX 5080 faster than the RTX 4090, thanks to AI. I don't know whether Nvidia will provide frame generation 4x to the RT40 series, and many of you will say, what about latency? First, don't expect a 30 FPS game to improve vastly and be enjoyable, even with frame generation set at 4x and with over 100 FPS final result. You need a stronger raster performance base for frame generation to work its magic, but thankfully the RTX 5080 is already strong enough to handle most contemporary titles. Frame generation 4x is not the solution for all, but it works wonders when the GPU is strong enough to handle the game's engine. This is the primary advantage of the RTX 50 series. Nvidia promises that shortly after the release of the new GPUs, 75 games and apps will support multi-frame generation. The other big news is the DLSS 4 transformer model, which is not exclusive to the RTX 50 series but refers to all RTX lines. DLSS transformer models improve image quality with improved temporal stability, less ghosting and greater detail in motion. There is a relatively small performance penalty, but as GPUs become more potent, we should focus more on quality than performance. The GALAX GeForce RTX 5080 one-click overclock is a strong graphics card for those stuck with an RT30 series card. If you have an RTX 4080, I see no reason for this upgrade unless you want the newest frame generation technology. Moreover, this specific model from GALAX has a silent operation. Matching this graphics card with an ATX version 3.1 PSU will be ideal with a proper high power cable, and avoid using adapters. You will find the best ATX version 3.1 PSUs in hardwarebusters.com. That's all, guys. Subscribe to our channel, like the video, share it with others, with your friends, with your family, and see you. Bye bye.